Hello everyone. Hello. Alright, so today we are going to continue what we started 2 days ago. We have a project on GitHub. We have a proper description of what is it and what it tries to solve. We have a basic implementation that will trigger an event every second and print it to standard output. And it's modeled based on the idea that we are trying to build. So let's continue from here. Right, so here is something that I did. I switched back to Spacemax because I noticed that when I was editing a file, the other file didn't see the edit, as if the language server protocol, the LSP thing, doesn't detect the file saves or doesn't listen to file notifications. So, and this is working in Spacemax, so I switched it back just now, and I updated to the latest version also, and updated the packages. So let's hope that the new packages don't have bugs. But the good thing is my muscle memory will work as expected. Because in Spacemax, I use Spacemax for years now. And when I switched it to Doom Emacs, I switched it because it was aiming to be fast. I feel it's cleaner a little bit. The theme feels cleaner a little. Yeah, but after I used it for the past 2 days, no, there is too many issues for me to just sit down and solve it. Um, yeah. Okay. So yesterday we had this. Yep, watch it. Right, so we had this. We create a context, and this context adds a rule. And when you add a rule, then you can start. And this is the rule. And the rule is it takes time and output time. It doesn't do any transformation. So here. So this is a source of time that is going to emit the current time every second. Then this action will do nothing with it. It will just output the input as it is. And 2 here is what to do with the output event. We can actually eliminate that. And we make it something that is so here. So we can make this like the default. So this then could be the default, right? It could be the default. All right. So add a rule first. Before we add the rule, we need to how to do that? Like amend the rule or like set. Let's call it as it is. Set defaults or set rule defaults. This takes in and out and the rule. Nope. No pointer, please. No pointer. We are trying to avoid any pointers in here. We're trying to avoid any heap allocations as much as we can. So let's see if this works. So we are going to do this rule. So yeah, if the rule then is nil, then come on, what's going on here? It's not the identity. It should be. I think there will be a problem here. There may be a problem. Should try to reference that, but anyway, let's see. So it's an actions dot yield, right? Yeah, if two, want one. Oh, that's another problem. You can't just leave it as it is, because if you leave it as it is, you have to make sure that the rule input is the same as the output. And this is the only case where you can use the identity. So, nope, we cannot actually do this. We can't do this. Yeah. And what we did is fire hose. Go run. Oh, we used also make run. And make run is like it's go run. And it output every second. All right, perfect, perfect. Now let's say we want to do something else. We want to have another rule here, and we will print only the seconds, right? So, or we will print only, yeah. So what I need is that I just need another rule with the same source, so I can start to code the part that makes a fan out. No, wait, before we do that, before we do this. Oh, Bo Hamza, Bo Hamza joined. Hey, how's it going? Sorry, I didn't see the chat. I think I have to put it up here. And I need maybe notifications for the chat and the desktop, but I really have a notification fatigue. Yeah, it's been a nice day. It's been sunny in Berlin, which is really rare. So some vitamin D. It's good. It's good. Most of us have a vitamin D deficiency, and we are just, taking pills left and right. Yeah, thank you. كل سنة وأنت طيب. So we are going to try to look here. This code. Okay. So we have the rule, the source, the action, and destination. We didn't do anything related to the condition yet, as in the if condition here. I have a library that parses conditions and execute it in runtime. It's a good library, and I used it in production for a while, but then, yeah. And it's pretty optimized, but I think it needs still more work because I optimized it for work, and that's not open source, so I really need to be careful. I really need to be careful. Just a second. Okay, so what I will try to do is that I'm trying to convert every rule into a callback, right? But the callback also is generic. You see, it returns the input type here as the input. So if I managed to have this as like free of the generic, then I can make a list of these functions. The problem with generic is that this is a different type every time. So you can have function of the context and int, and the function of the context and the string. And these are two different types, so you can't have something that looks like that. callbacks, and it's an array of function context to any, and you can't do this. So you can't have an array of function of any and then you have an int in it and a string in it. That doesn't work. So we need to unify the types a little bit. We need to reduce the generics in order to get a list. Oh, thank you. Yeah, we are trying to, the AI now you can one shot everything, and it's getting boring a little bit to do that. So this is more exciting, more fulfilling, and also not to lose my ability to code and think and criticize and like think slowly and try to build the stuff myself. It's a bit scary if you work with AI for a couple months and then you feel you are losing your edge a little bit, getting like rusty. So this is something we have to be careful of. Okay, so rule to callback. And the callback here, right, we passed it to start for the source. What we need is that for adding the rule, we should be adding it to a list. So a list of rules. This list of rules has to be stored somewhere. Yeah, this list of rules has to be stored somewhere, right? Maybe. So let's say, okay, because here's the thing. Let's start step by step. Okay, right now we are having the start when we add the rule, right? So that means, and that this is the problem. So if you don't do that and you just did ctx done and try to read from it. So if you do this, the code will still work, right? So that's the problem. Like this start function doesn't do anything. It just waits. And this shouldn't be the case. You should be able, when you start your program, to add the rules and then start. Why? Because if you have multiple rules listening on the same source, and then if you didn't do that, and you started to consume the first time you add a rule, so before you register the next rule, the event could go through the first rule. While when you are building this program, you want to all the rules that listen to the same source to process all the events. It shouldn't skip any event. Right? So if you have messages or if you have an HTTP request and you started to listen right away, you start the server listen right away the first time you add a rule, then the first request that comes in is going to be served only with this rule, not all the rules that should be executed when this request comes in. And that's a problem. So you need first to add the rules to the context and then start. Yeah, add the rules to the context. And that's the problem that I'm trying to solve also. That when you add something to the context, you are modifying the context. So every time you add a rule, you are just adding to the context something new. Yeah. So how we can solve this? Okay, let's do it the dumb way first and then try to improve it. So we need to move this logic from here to here, right? And we want to go over every rule. So we need something that looks like this. A range over rules, and then rule is, so we don't need to copy it. So let's get the address here, and we are getting the room, and then when we start, we are getting a context, I believe. Yeah, okay. If nil, blah, 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 okay. And you're getting a context. Let's keep it for now. Let's keep it for now. So this is the idea, is that you need to have a list of rules, and this list of rules has to come from somewhere, and that somewhere should be here in this context, right? Yeah, in this context. So this is the thing. This context must have a way to list all the rules in it. So you can but this is also another problem, is that the rule here is generic, right? So you can't have this generic rule here, but maybe this could be a closure. So we can have something that looks like this. It's a function, this, yeah, and it's a closure, right? So a closure, so yeah, a closure, and we just want to get the context and the error, right? And the context and the error. And we can do that. Okay, so that means we can just do this return, right? So that means we can make this here, it's a closure over the rule, and this context, yeah, okay, and actually we can accept the context here, context, yeah, right, and we can have like a, let's make it global first, and then we'll put it in the context. Okay, so we have the uh, callbacks or like activators, for example, and let's say this is like a slice of function that takes the context and return the source context and then error. And so this is an array of this type of function, and this function, let's say activator, and this activator is this kind of function signature. So we have a slice of activators, and when you add a rule, you are creating an activator out of the rule and adding it to the list of activators, right? And here you are arranging over the activators, and you are executing them one by one. Yeah, so we execute them one by one. They are returning a activator context and an error. If you try to do, if you try to activate something and it's an error, then you return early and we all go home. Otherwise, we need to collect all the context, right? We need to collect all the context, because here is the thing, like this is when you cancel it, no, yeah, if you cancel it, the source should stop, right? And if the source canceled it, you should also if the source canceled it, then you know that the source is done with its work. So it's a way for the source to tell you that it's done its work, and it's a way for you to tell the source that it should stop doing what it's doing. So it's like a two-way channel, kind of. Yeah. So we need to accumulate it, but later we are going to do something with it. Right, so now there are activators and we accumulate everything. Right, so I think it will work. Yeah, it's working the same way, exact same way. Okay, great. So now we have activators. We need these activators to be inside the context, not outside of it. Inside the context. We need a way to inject dependencies into the context. I think there are packages for this. Go package dependency injection into the context. Let's see. I remember there are packages. Yeah. Let's see what is that. I remember there were libraries that can add dependencies to a context. Type of reflections. Yeah, this is no. No, it's no, it's not. No, thank you. Merci. Okay. So what I need is I need a pointer to a slice of activators. No. Yeah. Okay. So I need a type that can hold this pointer, and I will put an instance of this type in the context so that every time I want to change the list of rules, I can get this type, go to the pointer, and I can append, I can change it, I can do whatever I want with it. Think this should work. So let's call it metadata. And the metadata should have also not exported, please. And activators is a list of activators. So we don't want it to be global anymore. We want a get or set in the context. Something like a get or set meta in this context. Yeah, no, it's writing itself. Okay, so we are trying to get the meta key. Okay, now I need a meta key. Didn't we create something like that here before, or did we remove it? All right. So the meta key, yeah, looks like this. And yeah, the meta key is just a type. And we shouldn't be allocating it every time, so it would be meta key is an instance here, and you use it here. That could copy it every time, I guess. No, but that would be hard to code it, so maybe the compiler would be smart enough. So if not, okay, you need to create a new one, add it to the context, otherwise you return get or set meta. All right, that's that should work. So what we are trying to do here, oh, look at that. So context meta, and yeah, so we got it, and n not activators append. Here you go. So now we have a list of activators inside the meta structure inside the context. But as we modify the context here, we have to return it. We can't, yeah, we can't just ignore that. Okay. That means the main will start to complain. There you go. Right. Get yeah. And now we need to get the activators from the meta. Yeah, activators. There you go. And then you go over them, and now we don't have the activators as global variable. Now it's in the context. We have a structure in the context where we can put the things that we need to pass around. So that means the user can use whatever context they want, and then we are adding stuff to this context. Does this work? It works. It works. It works. Okay. Okay, we are going somewhere here. Let's commit that. Let's commit this. And this is, what's that? My God. What's this? What's this retarded thing anyway? So we, how do we call what we did here? Keep track of activated roles. All right. So we can also, we are cleaning up, as you see. We have the role, source, action, destination. Let's just give them some space because they look really cramped. Yeah, all right. And we can keep track of the metadata between calls and add rule. Well, okay. Actually, I think rule to call back, and so do I have to create this function here, or can it be created here in role to call back? So can this return just that? Can it return that? Just this here? Because it has the rule, right? So it can, so yeah, that's a call, like activator. And then here is, it was doing that like when start, blah blah blah, and this was the function that the source will call, which was this function. Yeah, no, I think it's better to split them. Yeah, so this one is kind of starting the source. So this is an activator. Oops. So this is an activator, right? This here. So maybe we can just create a function that converts a rule to an activator. Rule to activator, right? And yeah, it will, oh, that's smart. Okay. So yeah, exactly. This is what we need. So this function is exactly this one, right? So what we want is just this, and we can say rule to activator, and then we are adding it here. You can even inline it if you want, if you're really into this kind of shit. So yeah, rule to activator, and then we activate the rule, we set it in the set, and then we activate it later. right? We activate it later. Does it work? It works. It works, bro. Right. Now let's come to the part that we ignored here. So we are activating all the sources, right? But when you activate a source, it returns a context. This context, when it's cancelled, it tells you that the source finished its work, right? Yeah, yeah, right. So I think what we need to do is to keep track of all of these contexts, so we don't throw them away, or because when we need them, this is the thing, like when the context is done, like the user context is done, because there's and context and said okay, start and use this context. So that means the user of the package, which is here, can say I will just cancel that after 10 seconds. So um, can do this ctx like context with timeout, and the parent is context and the timeout is 5 seconds. Okay, and this is context, right? This returns what? Context and cancel, right? And the cancel. So what happens is that if you run this program, 3, 4, 5, and done, right? So this context is cancelled now. So the program exits, and it exits before this is waiting for that context to be done. But that doesn't mean the sources that we just activated here are done. They may need some cleanup to do. So they already know that there is a context that is cancelled and they are listening to it. In the source, they are already listening to this, right? And they can do the cleanup. But it listens and do the cleanup, and meanwhile here also this is waiting, and there will be a race condition. So if this was executed first, then here this will exit the program, right? So it will exit earlier than these lines would be executed. So you can have sources that want to clean up and doesn't have enough time to clean up. So this is the reason where you need to keep track of the context returned from the source. And when the user context is cancelled, you wait for all the sources to finish their work. When they are done, then you can return. Yeah. So here. So what you need is to wait for sources to finish. And maybe we can have some errors. Maybe we should just return this, right? Yeah, so wait for sources to finish should have a list of contexts. So here, so contexts, we are making a list, and source context, and we add it to the list. Yeah. And here context. Yeah. So we are waiting for all the sources to be done. Now we need a function that exactly does that. Yeah. Yeah. It will go over every context and wait for them to be done. Is there a function in the context package that does that? let's see. Package dot go context. So is there like wait for all or wait for a list of contexts, like say after goes with cancel go style what? No, there isn't. Yeah. Anyway, okay. So actually, this. Oh wait, what are the nulls? We need maybe. We need maybe to accumulate some errors, like errors, like the channel, right? And whenever a context is done and the context has an error, you add it to a channel. Oh no, wait, it's not a channel of errors. It's yeah, like an array of error, right? And this is like a list of contexts. Okay. And here we need to append. Then here we can do this. There's the join. Oh, it's called errors or error? No, errors. The package is called errors. So let's shorten this. Errors dot join error. Yeah, and this joins. And the nice thing about this function is that if the list is empty, it returns null. It's pretty great, yeah. Append errors. Does this work? Okay, but I wouldn't know, of course, because our source doesn't tell me if it's done or not. So here, slog info, stop the time source. So we should see this, which tells us that the source was cleaned up. It's not done. Maybe because it's info sometimes. Error. There we go. 4, 5. No. All right. What's up with that? I suspect that the select case doesn't work as I would expect. That would be horrible already. Yeah. What's going on? So this is done. And we are waiting to finish. So what is going on here? So we range over the context. Okay, let's add something like so info. Does the info work? Does it really work? Oh wait, my favorite. Panic. So it goes here and it waits for the context to be done, right? Maybe I'm doing something wrong. No, here, source context and the context. Yeah. So that means the source This, I should see panics here. There is panic. So we're good. So everything is working. So why didn't I see? Oh, you see, I'm really stupid. Because this cancel, when this cancel is done, so this would be executed and is going to return, right? And my print won't work, so I should have did that. So here, before the cancel, not after it. Because once you cancel, the program exits. Here you go. What is this panic? I removed it already. Alright. We have a problem, Captain. Maybe it's buffered. Maybe it's buffered? No, even it's buffered, it has to be written. This, oh, okay. So the slog is not working. But when you print line, it works. Yeah. Okay. Sounds good. Sounds good. Alright. So now we are waiting for the sources to be done. Right? So the sources can do their cleanup, which is nice. Now the source cleanup. Right. So we have been writing a lot of garbage for some time now. So I need to set up some like tests, linters, some guardrails to make sure that what I'm writing doesn't end up like a big bowl of garbage. So, right, let's start with a linter. My fave. Here. No, not this one. Golang CI lint. Golang C lint. Golang C. Getting started. I also remember they have version 2, right? Golang. This is version 2.11. Nice. So, getting started. Yeah, I need to add it to the tools. Where's the installation, bro? Bro, where is the installation? Welcome, install on my machine. That's dump. Dump. Windows doc. Like, what the hell, man? Using go install, go get tools pattern, and the tool command direct installations aren't guaranteed to work. We recommend using binary installation. Why? Okay, so that's why. Okay, these installations are recommended because of the following points. These installations compile this locally. Yeah, that's fine. The Go version used to build will depend on your local Go version. Yep, that's what I need. Some users use -u flag for GoGet, which upgrade your dependencies. That's fine too. The resulting binary was not tested and not guaranteed to work. That's fine by me. When using the tool pattern, use or tool command directive. The dependencies of the tool can modify the dependencies of another tool or your project. The resulting binary was not tested and is not guaranteed to work. Yeah. We have encountered issues with Go module hashes due to an unexpected recreation of dependency tags. Go mode replacement directives don't apply transitively. Yeah. A user will be using a patched version of Golang CI if we use such replacement. Alright. Allow installation from the main branch, which can be considered stable. It's slower than binary. Anyway, and then he gave me this. We don't recommend using GoTool. Alright? No, I will use GoTool. I will use it. Dedicated module file. You should never update Golang CI dependencies manually. Dedicated module. What's all of this? Once again, we don't recommend that. Okay. Okay, thank you for your consideration. Okay, now I need to do this quick start. Go lint run. Because like we choose Go because it has a good package manager, it's fast to compile. So if your reasons is that it's slow to compile and the package manager doesn't work for your use case, then we have a problem actually. Right? So either a problem in the language or a problem in the project itself. So you know, let's just work together on this. Yeah, here you go. First issue that we found. So let's have this in the make file. Let's call this lint, and oh look, it's really helpful. It's helpful. It's like it's a tab. A tab. Yeah. All right. I really hate make files, but it just works everywhere. Okay, so make lint. So what do you have for me? Make lint. Directors are not analyzed recursively. To analyze them recursively, append this. Right. Let's lint them recursively. All right. Oh, this is equivalent of this. Okay, so I don't need that. All right. Can be used with zero configuration by default. Yeah. Formatting to format your code. Do this. All right. Okay. Formatters page. What are the formatters exactly? GCI import a statement according to Go font. Check if the code is okay. Check if the code's import statements are formatted with different rules. Go import go line. Long lines. Swaggo comments are formatted. You know what? Yeah. Let's do this. I need to add a configuration file. Configuration. Here we go. Command line. Where am I? Linters. List current linters configuration. Cache. Config. Okay. Version and verifications. Come on, man. Help me here, please. Configuration file. Here we go. Here we go. Okay. Let's have this file. and search for config files in all directories from the directory analyze. If no configuration file has been found, try to find in the home directory. Okay. So there is a reference file with all supported options, their descriptions. Okay. Okay. This is interesting. It's the whole thing. Right. Okay. So now if I do this, what happens? Cannot use enabled with default all. This file contains the available options. This one is not a configuration example. It contains the exhaustive configuration with the explanation of the option. Ah, okay. Default set of linters. The value can be standard. All. Enable all linters by default. None. Disables all linters by default or fast. Okay. And what are the default linters? Where can I? Ah, here you go. So it's error check, go vet. Oh, so I don't need go vet. So I don't need that. Static check and unused and inefficient assignment. That's a small set. Okay. Sure. So the default is standard. Standard. Okay, there you go. So if I do this, like cannot use enable with default to all, but it's not default to all anymore. The hell. Basic on. Okay. Apparently it's a mistake to. My God, that's 4,000. Okay, no, that's not the thing we need to do here. Okay, the conversion can be validated as schema and version and enters configuration. Okay, okay. We can do this one. This looks nice. Okay, so we have linters. Okay, I just need also to like take a look here, like linters, blah blah blah, version, blah blah. Okay, so first version, and then we'll get a list of linters, and the list of linters is like here. Okay, that's a lot. Wait, is there like a copy here? Yeah. Okay. So default set of linters. The value can be standard, default. Alright, enable specific linters. So it enables this and disable specific linter. Is it enabling the same set? So yeah, it's the same set. I think. So add range, yeah. So I guess what we will try to do is enable everything, all the linters, all variable settings of specific. So settings, cd linter settings, option value. Okay. Defines a set of rules to ignore issues. It does not skip the analysis and so doesn't ignore the type checker. Okay. Exclusions. Nope. I don't need any exclusions. And this is also right. Okay. So when I do this, it should take time. Is it taking time? Right, 37 issues. And we didn't even write anything yet. The length of AWS is deprecated. Continue measure version replaced by. Okay, so WSL. WSL. Oh, so we shouldn't use this. Okay. What's up? Go mode guard is deprecated due to new measure version replaced by the version 2. Right? There's like page up and page down. Wasn't there like something like this? Damn. Maybe it was like command page up. Alright, so we have import. I have an automation that turn off the lights at 10 p.m. which signals me that the day ended. So. Alright, so is not allowed from list main. Importing this is not allowed from list main. Okay, now I need to understand what's that. That's a nice linter. So it checks for the imports. Okay. And this one is not allowed from list. I'll say okay. Error return value of this is not checked. That's pretty good. This is pretty good already. This rule is missing field F. Nice. It tells you that you missed some stuff. This is missing field activators. Perfect. So it okay. Yeah, that's a nice one. Fed context, nested context in loop. Nested context in loop. Okay. Use println forbidden by pattern. I shouldn't be using println. That's alright. Yeah. Meta key is a global variable. Yeah, it is a global variable. Maybe it should be a constant. Okay, but let's magic number 5 in here. Yeah. Return with no blank line before. There are some nice stuff. Unused parameter in here. Oh. Exported type should have comment or be unexported. Exported method. That's yeah, all of that we need to do. Okay, first let's just put this here, and then let's ask it to autofix. I remember it has an autofix. So how was it? To fix, like fix command line fix. Apply fixes detected by linters and formatters. Here you go. Alright, so make. So that means we just need to say fix. Okay, this is nice. "36 issues. Oh, make fix. Did it fix anything? I think it broke something. Non-name context on left, blah blah blah. Oh yeah, so I guess the fix actually broke the code. Anyway, so this is okay. So why? And this is splitting that, okay. Why did it do this? Okay, maybe we should use the normal pattern, you know. So context, append, no, maybe it's triple the linter. Also let's do this here, here, and the fix. All right, now continue to fix. It's 32 issues now. 32. It was what, 37? It didn't fix a lot of stuff. Warum? Warum? Apply fixes detected by linter if it's supported by the linter. So all of the rest of them are not supported? Really? That's interesting. Okay, okay, let's leave the dependency guard for now. This main. It's talking about this, right? Like 25, yeah. So if error doesn't panic, let's all panic. By the way, I'm not sure if the audio is fine or do I need to improve it? Because I don't hear myself. And I think there is a music in the background, right? So is it good? Should I make it higher? Should I make it lower? Just I need some feedback to know what to improve. And because it's too silent in the chat, so okay. All right. Okay. So this is not checked, and now we check it. 31. We can do it from the bottom here. Error returned from interface method should be wrapped. Rule 69. Ah, that's a good one. I made this mistake multiple times because when you return the error as it is, you really never know where did it fail. So is there? So it's like fun error if, and you need to say failed to process the action. This is like error if and or like action failed. And I think here it's the same. Yeah, destination failed, exactly. So return now. So I think we need to pay attention to this kind of things. Yeah, returned error extended package is wrapping, blah blah blah. So standard output then. Nice. Variable name M is too short. Eh, right. I'm not sure if I like this rule, but let me follow it to the letter. So 42. I'm bored a bit. I think I need to play some game. It's 10 p.m. Maybe I can play for half an hour or an hour. So what is that? This is meta. Hmm. It can't be meta. It has to be existing. Exported method time start should have a comment. Yeah, should have a comment. So it's gonna bother me with comments all the time, right? I'm not sure I should do this one. I feel it's a bit time consuming, but also it will tell me, I will have to pay attention to what's exported and what's not. Because sometimes I used to do functions that shouldn't be exported. It's like helper in some structure, and I export it. But because I don't enforce the documentation over the function, I never really notice it that much. Yeah, let's do this. But let's have it in the end, because it takes some time. And also I can make the LLM do it. It's sorry, yeah, it's very daunting. Let's fix yield. Wait, can I make the AI just solve all of this stuff? No. Magic number 5, global variable. Yeah, let's see. Open code. Run make lint. Fix the issues as much as you can. Don't do no lint or exceptions. And iterate until all issues are fixed. Or yeah, okay, yeah. Let's see what's gonna go sidebar. Right. You can use different settings. Let's examine the files to understand the structure and begin. Yeah. I now have Do you really have a comprehensive view? Do you? Okay, so now it adds rules for what should import what. So the main is allowed to import the standard and import the fire hose. So you don't import any shit without adding it here. That seems redundant a little bit. But okay. It adds documentation. Documentation. Yeah, this is the daunting part. Yeah. What did it do here? Meta key value. I don't get it. And here it added the activator. Comment. What is it? Timeout duration 5 seconds. Okay. Exhaustive. var instead of const. Really? So he removed the package name and said, yeah, we can just do this. Ignore names. God damn. I return allow generic. I don't know what is that. I will remove it and see what happens. And then continue to add comments. For global variables, I need to either disable the linter or refactor. This I handle this one idiomatically. Yeah. So there is the type, meta key, select meta key context, and then what? What are you doing here? It removed the rule. Oh, it added inside. Okay, yeah, because it's global variable. Okay, sure, no problem. Imports again, yeah. So is it gonna solve it? Go check globals, ignore type declaration. Huh. Still getting it. Still getting the importation. Prevent unmaintained packages. Then it added just some shit. Deny some other shit, like this is that the main list error message might be creating default main rule. Let me disable the default. Wow. Main list is case sensitive and might be hard coded. Let me search go to quitting. Okay, so it removed what it added before, right? Okay, then what? And disabled the linter completely. Okay. Good work. Now I need to fix the 3 issues. Yeah, bro, you just ignored the stuff. Looks correct. The issue is that ignore type declaration for doesn't work for all global variables. Let me use the correct approach. And what is the correct approach? it's really, it's really fun to watch the AI. Sure, bro. Use the correct approach. Okay, so you have here meta key, and then you use meta key. Okay. In context, you're using meta key. Meta key is a struct. I can use the context string. Maybe I can use string. What are you doing here? Head. Oh, okay, you renamed it to callback. Okay, good. What's that? Process return generic type of type param any. I don't get this one. Like yield 10 returns generic interface T of type param any. And what's your problem exactly? Oh, you return. What is that? What does it do exactly? Accept interface, return concrete type. Ah, alright. Work with 2 arguments, but allow to use only one of them in the accept reject. So you check that you're accepting an interface and returning a concrete value. Hmm. Uh, wait. You will spin indefinitely, maybe? Zero issues. Okay. What have you done? Wait, okay. Does it work? Make run. Does it work? Error in time. Okay, now we have this. Destination failed. Error in syndic event. I think we added this in the wrong place. Yeah. It should be all right. Okay. So let me check. So a comment, timeout duration. Okay, and move that. Okay. This one looks good. These changes are fine. And then in yield, it added comment, and yeah, perfect. Comment import, and then it used write string to standard out, which is what? Okay. Yeah, gonna dig in the living room. You're gonna dig in the living room. Dig in the living room. هات بوسة. تعال. هات بوسة. تعال اقتي. يلا ولا. He ignored me. ماشي. براحتك ماشي. So, okay, this one also looks good. These are comment. And what did it do here? So meta key is a struct, and okay. I think what's the problem? String. We can do this const. I don't know why it didn't really do that. I have no idea why it didn't do that. Back key value. Make int. Should not use basic type string as key in context of. Huh. Remeta key is unused. Where is that? Rule 41. This is why it's failing. Unnecessary. Yeah. See, I don't know why it didn't do that by itself. Unnecessary white space in standard output. Where? Line 16. Cool. Okay, so this one. Now this is fixed. Okay, let's leave this to the end. Okay, so source time. This is comment, and what's in there? Oh, it renamed the CP to callback. Okay. Right. Meta key string. did it do here? Okay, so it's the new type, and it initialized the activators. Time. Okay, and now let's check what did it disable exactly. It disabled the I return. Okay, so I return, it shouldn't be even here. So should be fine. Okay. And the dip guard, I need to read about this one. Dip guard. That checks if the package imports or in a list of acceptable packages. ARA in I saw it, I've read it all. Yeah, I think it's getting late. I should have played some games. Haven't played for some time now. Okay, yeah, I don't think we need this linter. Dip guard. Yep. Looks good. Now, these are linters. What are the other parts? Okay, so first let's... Oh, and this one. Go check globals. Ignore type declarations. Why? Why do we ignore the type declarations? So if I remove this, what will happen? Nothing. Nothing. Yep, okay, so now we have all the linters. Add linters. And good boy, the AI already helped us. Okay. Okay. There are also formatters. Because like in the linters, there was this like cycle. Yeah. So this one. Linters, settings, okay, let's do this. Linters, settings, cyclomatic complexity. That's what I'm trying to... I think I can have it in the end. Okay, the maximum code complexity to report. Max complexity 10. Let's see if we passed in. Maximal average package complexity. If it is higher than... okay. Let's see. Is it higher? It is higher. Max. Oh, what is this? Average complexity, blah blah blah. Okay, the average. Okay, no, I never used this average, to be honest, and I don't want to use it. Max complexity 10, that's a high bar. That's a high bar, yeah. Sorry, that's a low bar. So it's really easy to hit, like if it's 10, that's... you're not even trying to simplify anything. So let's try 5. Now we are talking. So time and 23 or 32? 23. Yep. So this function has cyclomatic complexity of 6. So what can we do? We can extract this function somewhere else. And this function, we can call it... wait, what was it doing exactly? So it was waiting. Yeah, it was emitting the events. It was emitting the events, right? Yeah. So maybe we can call it like T line emit, and it's like emit, right? But then you need to give it done, give it cancel the ticker, and call back. You are giving it everything. And here, oh my god, here. Cancel ticker and call back. Yeah. Mm-hmm. Um, Wait, do we need context here? Yeah, we need context. We need the original context. Yeah, the original context and the done context, the cancellation, and the ticker, and the callback when the ticker do something. Okay. Calculate the complexity of the function, and it emits 6. Okay, 32. Still. Oh, for function emit. It's 32, not 20. This. Okay. Why? Calculate the chromatic complexity for function emit is 6. Okay, this is complex. Okay. Is it complex? Maybe we can do this. We can extract this part into a function and we can call it like a tick. T tick. Now let's see. So here. So the tick, this code needed a context. So first thing, context. First thing. And then it needed the time. And callback. Yeah, it needed a callback. So it needed a context, the time, and the callback. The line is too long. 146. Where is that? Line is 32. Yeah, this callback, maybe we can have it as a type. Yes, because it's repeated in other places. So time CP. Time event callback. Okay, yeah, that's pretty good. And let's define it here. Time event callback. And then time event callback. Event callback. Here you go. How about that? Damn. Yeah, so his problem is that this, which is like a function that takes context and time and return an error, which is this, for the compiler, this is a different type completely. but it's the same type. But anyway, so we can solve this by making it a type alias. So it's not a new type, just a shortcut for the type, just an alias, you know. Perfect. Line 32 still too long. 32, this one still too long. Why it's too long? Because 3 characters. Yeah, so we actually can do that. Time codec, and that will solve it. That solved it. Nice. So a cyclomatic complexity of 5 is achievable, and actually it looks good. So here actually the emit shouldn't be called emit, like should be called something like it's not emit, because emitting, you are emitting an event, so this tick should be called emit. Here, this one should be called emit, and this one should be called, because you're emitting continuously, right? So it's something like what to call it when you emit continuously? Maybe we can call it like a ticker, the tick. So with every tick you are emitting the time. Mm. Okay, that's for the cyclomatic complexity. Does it work? It works. Nicely works. All right. Okay. My next thing is the escape heap analysis thing. So is there a linter for this? Like heap, escape, forbid, forbidigo, go, somopolitan. What are these? What is that? That looks interesting. What is that? Report certain internationalization, localization, and type pattern in your go. No, thank you. It's not that. Forbids identifiers. So it tells you not to use stuff. This is actually useful. I used to write that manually, like by hand, like a test. Okay. CI lint and heap escape linter. Memory usage very high and not execute blah blah blah. Okay. So this is supported annotations must inline. Check if the function was inlined at the console. That's nice. Go escape lint is a linter tool for Golang that checks for unsatisfied escape analysis constraints. While you can't force the Go compiler to inline a function or avoid heap allocation for a variable, true, you can at least verify if the compiler is optimizing your code as expected. Right. This tool helps quickly detect situations where performance critical paths in the code are not optimized by the compiler due to unintended changes in the. Yeah. dependencies or compiler itself. This is achieved by introducing special code annotations and comparing those annotations to the actual escape analysis output. Perfect. That's good. This is really nice. I do this. So go tool and then how I need to install. I need to install as tool. No? No, install CLI as project tool. I know this feature exists. What's going on? Okay. Go. Tool. Exactly. Run specific. It's run specific. So what if I want to install it? Okay, so here you go. So go install. Yeah. Go install. Alright. The hell, man. Go mod tool directive. Tool chain directive. No, not this one. Sorry. It's the tool directive. Here you go. Yeah. So since 24 we can do this. And yeah. So you do that. Okay. So mod, and you can say tool, and the tool you're trying to install, which is this one. Then what? A tool directive at the package available to run. Okay, go tool, and the package we are trying to run is called go escape lint. The requirement you provided package to edit, but I have it. It's called tool. If the tool is not in the current module, a required directive must be present that specifies the version of the tool to use. The tool meta pattern resolves to the list of tools defined in the current module. Go out in the workspace. The union of all tools. What am I missing here? Go mod ID. Finding exactly. Okay. Perfect. Okay. Go escape link. All right, we did it. The annotations are placed as comment in the code and are parsed by the linter tool. They must be placed in the same line as the code they are annotating. Okay, must inline. No bound check. Oh, here we go. No escape. Apply to variable declarations. Ensure that the variable does not escape the heap. The linter will produce a warning if the variable escapes. Well, that's not what I'm looking for. You know what? Go build dash C flag. Is it? C flag. What was it? Go build like the optimization. Again. So C flag dash M, I think, but I really need to see it. Dash M. C flags. GC flags. Okay. Go build dash M. And I just want to protect the implementation that's in the root directory, not the subdirectories, because the subdirectories are examples of how to write sources and destinations and actions and input and like events and stuff. So what I will try to do is the main hot path, which is the engine itself, should not be allocating memory whenever it executes rules. The hot path, yeah, that's what it should be. So only this. Yeah, only this. All right. And we need to check for specific ones, which is escape to heap or move to heap. I don't see move to heap here. Okay, we can make it like so. Oh, wait a second, we need first to remove this. Here, length. Go build C flags dash M this. And I'm trying to check for this. Only it. Go length. Not length, sorry. Flag provided but not defined. Oh, it's not good. Yeah, I think I need to stop streaming now because my brain is not braining anymore. Yeah, no, it's go build this. What's going on here? See, GC flags. It's called the GC flags. Okay, GC flags. Here you go. Inline call leaking. What, bro? I have a pipe here. I think this returns a status 1 as if it's error. It doesn't return 0 to the operating system. So I think this command kind of fails. So I need something to tell it, hey, like and something like with 0 or something. That's not and like damn. So what I'm trying to do is that this command returns the status 1, which means make will not continue. So how to go make ignore status error return code. To ignore errors in a command line, write minus at the beginning of the line text after the initial tab. I didn't know that. So here. Okay. But grep escape to heap, I still see everything. Maybe this is the standard output. Standard error, not standard output. So I think it was 2 and 1. Redirect steady error to steady out. How was it? Yeah, 2, 2 and 1. Yeah. Always forget it. Cool. Now we don't want the command itself to be printed. Nice. So now we know all the escapes in the main package. The meta key escapes to heap. Okay. The meta object itself escape to heap, of course, because we allocated there. The activator array escapes to heap. The meta key here also escapes. Okay, so and the errors, same. That would be the hard part. The hard part is to eliminate these, not coding the logic and stuff. It's to eliminate that. Oh, hello, Elemental Magic's card game. That's a really long name. Like, okay, that's a good one. Elemental Magic card game. Are you making a game? And this is like your what's the story behind this username anyway? All right. all right. So I need to eliminate some of these. And it's already around 11 and I need to end my day. So we today learned something new. So in GNU Make, if you make a minus in the beginning of the line, it ignores the error. So learned something new today. So nice. Add escape to heap check. Perfect. Yeah. I just want to check something. So rule line 49. Rule 49. Here. This. So this is if you try to get the meta and it's not there, because this is get or set, so it has to allocate, right? So if we're not trying to get or set from the context, what else can we do? What else can we do? Right? Like you have to allocate it. You have to allocate it. Wait, do you? So I say meta here is a pointer. But even if you have it as like a concrete value, like as an actual value, if you copy it, no, if you copy it, nah, still. still. So how do I avoid this? How do I avoid? Okay, let me ask the AI. Maybe it can give me an idea. New and it's line 40, 49, right? Yeah. Let's just make sure we committed everything. Okay. Line is there a way to avoid this heap location? Is there? This is Sonnet 4.5. It's not the latest. Yeah, sure. Of course. Examine the code. Yes, I see the issue. Okay, yeah, I already told you. It's being stored in the context via with value, which require interface and thus forces heap allocation. Several options to reduce heap pressure. Pre-allocate with capacity. Minimal changes. Man, that's not the problem. You are like suggesting a solution, not for the problem. Yeah, okay. Uh, use sync pool. If contexts are short-lived, yes, yeah, but if you do that here, you will have the skip to heap. Store value directly, avoids pointer, alright? Existing is this, then use the value, and later existing with that. But so every time you add a rule, you try to find that, you will get it, and then you append to this, right? Wait, how is that? How is this working? So get set, and then yeah, we are assigning it again. We're assigning it again. Now let's keep this. Yeah, that wouldn't work because that means every time you change it, you need to add it again to the context, which is still escapes to the heap. You didn't really do anything now. Like students of the recommended, accept the allocation. Recommended, stop programming and just go home. Context with value always causes heap allocations. And that's a good point, actually. Yeah, it is like it's really hard to avoid this allocation. Maybe I need to change the whole idea of adding the value to the context. That's its design. The pointer itself is tiny. If this the path isn't called millions of times per second, the cost is negligible. Yeah, but it's a challenge and we need to solve it, so just let's cooperate with me. How frequently this is called in your hot path? If it's once per application lifecycle, the allocations are relevant. Yeah. No. What I need is that when you give me a context, I need to know what are the rules for this context. Can I make the rules like a dynamic array where every rule is pointing to the next, and giving me a rule means I can iterate over all of them? And that means rules would be allocated on the heap and passed by a pointer, right? But you allocate the rules already. Yeah, I think this is possible. But then, what's up with the context? So the rule itself could have the pointer to the next rule, right? Yeah. So we can make them as a dynamic array. So that means when the user create the rule, is already creating the pointer that I need. Let me check this theory. Okay. So we have a rule. And the rule internally, we're not gonna tell anybody. There is next and the previous. And it's a rule from any to any. So yeah, but from any to any, I can't assign any rule. Yeah, that's well, it won't be a rule from any to any. It will be a rule that's any. Next and previous any, and the any is boxes, right? It boxes the type, so it will make an allocation. Will it make an allocation? Okay, let's think. So if I do this, I will have a list of the roles. And maybe I can have the rule have an interface and can have this here next and previous as an interface. And the interface itself can do this logic. Like it can return an activator. Yeah, I can have Yeah, I think this should work. So this rule has next and previous, okay? And then, so let's make this as like our rule, and it's not a string, come on. Set next. Yeah, set next, and next will be another like in of any. And we will come back to this any. Wait, we can maybe make a small interface. Trying to avoid the allocation. It will get complicated a little bit. I can't expect it to be that simple. So our next in, okay, and this set previous, and it's going to set the previous, and our next in, so in dot set previous. Yeah, exactly. So now you need an interface. Okay, you need an interface rule activator, which is in and out. Yeah. Yeah, it's not generic. It doesn't. It's not a generic. Yes, exactly. No, not start. Come on. Set next and set previous. And I can have this. Let me call it like rule int, as in rule interface. Rule int. Okay. So set next. Oh, and here rule int, right? And here is also rule int. That would be great. Okay. It will be glorious. So next set previous or no, I think it would be recursive if we try to do it that way. Prev. So you set next here, because if you do this and then you do this p set next r, it will be recursive, right? So let's say you have a rule you're setting next in, so r next in, and then in previous r, so it will come here. It will set the previous p, and then it will go for p, set next, it will go here, and so on, right? So when you get that is becoming object oriented. And it shouldn't be, should be rule int. Rule int, yeah. So get next, set next, get prev, set prev. What's wrong? Something is wrong. What did I do? Something is missing here. Yeah, this if. All right, so if the in.get prev doesn't equal the current, then set it, or equal current, return, right? Like return early, as we usually do. What's going on? Expected something. In.get rule. Yeah, what's going on here? Okay. We need a way to check the equality. I don't know if this will work, but anyway, rule cannot convert R to type or int, does not implement or int missing, get next. Oh yeah, so we will get it, don't worry about that. So if p get next return, right? Yeah. And we need get next and get pref, right? So now you can set and get next and previous, and you're not allocating anything, are you? You're not allocating, you're passing pointers and assigning pointers. So if I do this, it shouldn't. Set next must be named param. Oh, this is like a linter. This is not the escape thing. Yeah, you see. So nothing is escaping because we just assign pointers. Interface method set next must be named param for type. Must have named the param for type rule end. They must have named? Really? They must or must not? Set. So it's in line 39. Next in previous. Happy? Export. Yeah, we'll add comments later, but okay, this is the important part. It's this here. Interesting. Okay, so it's not escaping. I think I can use this pattern. I think I can use it. So what we are going to do is to try to have the rule, because the rule is aware of its own type, right? So I can add to its interface a way to activate or return an activator. Yeah. So you can do something like this. Here, activator. It returns an activator. Yeah. What's your problem, man? Cannot convert R to type. Doesn't implement the new method. We just defined this method, so calm down. Rule to activator this one. Okay, so this one needs to be in the rule. So it would be glorious. Activator, and it returns an activator. Can you use this as this? Don't worry about it. Can I see what's going on? So activator takes. Oh, we don't need the rule anymore. So rule, and we don't need it as a parameter here. And do this. Does not match. Yeah, this callback should be taking a pointer now. Pointer. Why? Because does this work? Called add rule in the main. Yeah, in the main. Okay. I think we're good. Or you can you can do this, I guess. It will work, it works. All right, so yeah, I think we can use this pattern. So now you have the activator. The rule itself can return an activator, so we're good. And that means you can iterate over elements that return an activator. And now we were modifying the context, right? So now we don't need that. We need to return the first rule in the list, right? So you activate, it adds it to the list, and then I return the first one for you. And this is the one that you should be always using. Okay, I think I can continue tomorrow, but I think that's a good line of thought. Yeah, so the user is allocating the memory and I'm just passing pointers and assigning values when I want to and iterating over the memory. So I wouldn't be allocating as much as I can. And when you iterate over it, it's an interface. So you can ask it to do stuff for you. You don't have to know the exact type. Yep. Let's see if this works. What I'm thinking about is that boxing, maybe this boxing thing, when you pass a type as any or as an interface, it kind of boxes the type, right? That makes an allocation. We'll check. We will check. But and rule activator, rule to callback, start. All right. Yeah, I think I'm out of energy already, so I think I'm done for today. But I think I learned something new today. I learned how to avoid the escaping to the heap as much as I can. The whole idea is not to make any new objects. Whatever you want, get it as an input. Will this work? Yeah. I think the add rule thing. It shouldn't be adding it, it should be like here. It should be like an interface or something. So the rule would be boxed as an interface. So I think it will be something like this. Registry. Registry. The comma here. Yeah, so I think it will look like that. And you don't roll to okay. So you don't do this. You are passing context, the registry, you know, and that's okay. Registry is null in the beginning. Yeah. And when you're done, you return the so role to activator, you don't do that here anymore, right? You don't need to get anything from the context. And you even don't need the context. Or at least not yet. And activators, there you go. And so you return the role. So if R is nil, then R is the role. And no, if R is nil, just return the role. That's it. Yeah, it's your first rule. Well, what's wrong? Not enough return. Oh yeah. Right? So you're returning the head. If there is no head before, you return the rule as a head. Otherwise, you would R set next rule. And rule dot set previous R. I think I shouldn't have in next and previous. I shouldn't get previous and shouldn't do this. There is no need to do that. Right, this function is dead now, and you are setting the next and previous. So the head. Okay, no, we need maybe. Because when you activate, you want them to be in order, right? So maybe we can make them in reverse order. That would be easy. So you can always return the rule, which is the last one, and the rule set next should be the previous one, and R set previous is the rule. So you are linking them together from the last one activated into the oldest one activated. So when you iterate from the last to the beginning. So the rule next, yeah, because the rule is empty, doesn't have anything. So it can be the new head. You can just set next, the other one set previous, and we're good. Yeah. Yes. And now you would look at this. Meta activators, you don't need it. Meta key, also don't need it. This one, you don't need it. Get or set meta. Okay, and here. Now, when you start, you get a context and registry, or as in registry. And all you need to do is to go over every registry, get the activator, and activate. Yeah, we don't know how many of them are there. So, sorry. Let's do that here, and we will see how we solve that later. So, okay. Yeah, exactly. It is exactly like that. So you're going over them. Activator is R activator, gives you the activator, and then wait, the activator should, I think, take a context. Yeah, you see that? Oh no, doesn't need to. That's the beauty of it. All right. Source context. So activator. Right. You're appending. You're done. That means you're going to activate right away. That's a problem, and we said we don't want to do that, right? Yeah, we wanted to get all the activators and then exactly, so we wanted to map everything to its own activators. Activators, append, activator, exactly. And so you get the whole list. No, it's the same thing. Yeah, and I'm trying not to activate them in order because if there are multiple rules that subscribe to the same source, they should be first like activated, like fanned out together. Yeah, fanning out, no, we will solve fan out later. That's not a problem for us now. But definitely it's a problem for our future. So main. Yeah. Okay. Okay. And this is getting registry and nil in the beginning, right? Declared but not used. I know. And R. Right. When you do this, it should work. It's working. It's working. It's a linked list. It's a basic linked list. And if I make linked, is there anything that escapes to the heap? Okay, joining the error append. So it's line 129. Rule. This one. Yeah. All three ones, we eliminated the escape to heap. We eliminated it in the previous stuff. Now we need to find a way to eliminate this one. Okay, now we know. So I think our problem here is that we allocate and it outlives the caller, right? So this outlives this function. So this function return that to the outside. Yeah. So it allocates a memory, adds the rules in it, and then return it. So this is why it says that it skips to the heap. But we'll solve that tomorrow. But I'm glad we were able to solve the skip to the heap first occurrence. I wasn't expecting that, but it needed a little bit of mind bending. Yeah. Okay, let's do that. Okay, all right. I think that's enough for me. It's like 2.5 hours. So thank you for attending again, Abu Hamza. It's really nice to see you every time. It's good. And maybe tomorrow we can continue with that. Tomorrow we can continue. Yeah, but it's really exciting. The idea of eliminating memory allocations, like escaping to the heap, it's pretty good. It allocates memory, but most probably it allocated on the stack if the compiler says it didn't escape to the heap. I can't really know for sure, but compiler is telling me, so yeah. Anyway, thank you very much and see you.